The one for today, we're finishing the one from yesterday. But you'll need that one too. All right, guys. So this one here, so we're starting off, we're going to do a few from the one yesterday that we didn't get to. And then we'll start the one from today. So what we finished up with yesterday was least common multiple. So we're trying to see what we need to make all these terms into be so that they are the exact same.
Y minus 2 and then y plus 2 squared.
Yes. Because if we look at these three terms here, we have y minus 2 and y plus 2, and then y minus 2 squared. And really the y minus 2 squared, or y plus 2 squared, is telling us that we have a y plus 2 times y plus 2. We have it twice. Because whenever we square something, we're saying that it's multiplied by itself. So if we look at both of these here, we know that we'll need at least one y minus 2, because it does occur once in both of the expressions. We'll also need a 2. Is there anything else that we'll need? Yeah, we can square. We need 2 of them. So we can either write it as y minus 2 times y plus 2 squared, or we can say y minus 2 times y plus 2 times y plus 2. Either one of these are going to be the exact same thing. There's just different ways to write it. But that's it. That's what we need for both of these to be the exact same. Any questions on this here? Okay. Let's look at this one here. Least common multiple. Now, just like the last one, the x minus 1 squared is really telling us that we just have x minus 1 times x minus 1. We have it twice. Well, for the least common multiple, it means that we'll need the x minus 1 twice because it does occur twice. We would also need the x squared, yes. So the first one has an x and an x minus 1. Do we have it contained in the least common multiple? Well, yeah, because 1x is contained in x squared, and the x minus 1 is contained in our x minus 1 squared. So we do have it. And that's actually all of it. This would be the least common multiple. It would end up being x squared times x minus 1 squared. And that's actually it. Any other questions on this here? Let's go on and look at the next one. The old one, because we didn't get to finish it. Because we have this one and one other, and then we'll be finished with it. So we didn't have much more of the old note sheet left. Now this one here is a little bit different. Because this one here we actually need to do some factoring to see what would be contained in the least common multiple. Now the x minus 1, x squared minus 1 will factor to x plus 1 and x minus 1. Because it's a difference of perfect squares. Now we'll also need to factor the x squared plus 2x plus 1. We have our two sets of parentheses. And it does work out to be x plus 1 and x plus 1. And it works out this way because it actually works out that it's a perfect square trinomial is the name for it. And even if we worked it out the other way, since the 1 is positive, signs are the same, they match the sign of the middle term, which would be plus and plus. Factors of x squared are x and x. Factors of 1 are 1 and 1. So what's something we know we'll need for the least common multiple? We'll need an x minus 1. So I wouldn't say 2x plus 1, but what? Yes, we would need 2 of the x plus 1, yes. So we would need 2 of those, x plus 1 and x plus 1. So we get x minus 1 times x plus 1 times x plus 1. Well, if we wanted to simplify it a little bit, we could say x minus 1 times x plus 1 squared. And that's it. That's all we have to do for these here. Any other questions on these? We can go on and look at the last one here. And with this one here, well, t, since it's by itself, we don't have to do anything with it. Now the t squared minus 1, t plus 1 and t minus 1, it's a difference of perfect squares. Didn't really need that extra parenthesis. Now it does work out that t squared plus 5t minus 6 does factor. The negative 6 tells us that the signs are going to be opposite. One's going to be positive, one's going to be negative. The factors of t squared are t and t. So we have 2 and 3 or 1 and 6 for the factors of 6. Which one do we want to use? 1 and 6. Because with 2 and 3, since they have opposite signs, we'd either get 3 minus 2 or 2 minus 3, which would give us 1 or negative 1. With 6 and 1, 6 minus 1 would give us 5. Now we need to find the least common multiple. So looking at this here, what is one thing we know we'll need for the least common multiple? T. And then?
T plus 1 squared,
So t plus 1, yes, because here we do have one of them. But that's it. That's the only place that it does occur, so we only need it once. So we will need a t plus 6, yes. And the t minus 1 and t minus 1 do appear twice, but in each term they only appear once. So we'll only need it once. Now if one of them was t minus 1 times t minus 1, then we would include it twice. But here, each time it only includes once. And the t plus 6 only occurs once. So we only need it once. And that's it. Any other questions on what we did yesterday? Yep. Well, there we go. We'll have to go and blur that out later on. This is going to be the new one.
get out there.
4. No, they test the siren every so often. All right, guys. So what we're looking at today is addition, subtraction. Now, for the most part, addition, subtraction is really nice if the denominators are the exact same. So if the denominators are the same, like this one here, then we can go on and add and subtract the numerators. So the ones where the denominators are already the same are kind of nice to work with. So here, since the denominators are already x minus 5 and x minus 5, we can go on and add the like terms in the numerator. Well, x doesn't have a like term, so it'll just remain x. But the 6 plus 2 becomes plus . So when the denominators are the exact same, it works out kind of nicely. Now, once we get finished here, we do need to remember that when we have multiple terms being added together, they're one unit, they're one term. So the x plus 8 is one single term. The x minus 5 is one term. And that means we can't just simplify the x and x because they are connected with the other terms that are being added and subtracted from them. So for us to be able to simplify, we need to be able to factor anything out or get it so that we have things multiplied together. Now looking at the x and 8, are there like terms between these two? Well, no, there's nothing we can factor out of the numerator or denominator. So that right there is the final answer. Because if we can't simplify anything by factoring it out and then simplifying on top and bottom, that's all we can do. Questions on this one here? Let's look at the next one. Yes. Well, at 3:10, I can go home. No. But all right, guys, let's look at this next one here. So the next one that we have is this one here. Now, again, the denominators for these two are the exact same. So we still have the same denominators, which works out nicely. So we have x plus 5 times x minus 2. Yes. Now we can go on and add the like terms in the numerators. Because x squared is the only term that has x squared, it stays the same. Now we can add 3x and 4x, which gives us 7x. And negative 2 plus 12 is plus 10. Now, before we can say that this is finished, we do need to make sure that the numerator and denominator don't have any like terms. And to make sure of that, we do need to factor the numerator. So in the denominator, we have x plus 5 times x minus 2. So the numerator, since the 10 is positive, the signs are the same and they match the sign of the middle term. So we have plus and plus. Now the factors of x squared are x and x. And the factors of 10 are 1 and 10 or 2 and 5. 2 and 5. Well, that does show that we have like terms with our x plus 5 and x plus 5. Which leaves us with x plus 2 over x minus 2. And this works out to be the final answer. Now, if the signs for both of the terms on top and bottom were opposite, then we could actually factor a negative out and have something in common. But here, the x and x are both positive. The 2's are positive and negative. And what I mean by that is if we had negative x plus 2 on top. Well, now the x's have opposite signs, the 2's have opposite signs. And if we had factored a negative out of this, we would get x minus 2, so it would match up. But most of the time, like this one here, it won't work out. Because we would still have opposite signs for one of them. Any questions on any of this here? Let's look at this one here. Now, we'll eventually need to factor the denominators. But are the denominators the same? Yeah, so we can do that later. We can go on and subtract the numerators. And the way we've done this before is that we rewrote it with each numerator in parentheses and the subtraction sign in the middle. But what we can do is we don't necessarily need to do that because the signs for the first one aren't going to change. And what we're doing here is we're subtracting the numerator of the second from the numerator of the first. So that means we're going to be subtracting x squared, which would be negative x squared. Next, we're subtracting the negative 4x. Well, subtraction of a negative would be exactly plus 4x. And lastly, when we subtract a negative 5, the negative and negative make a plus 5. And again, when I rewrote it before with the parentheses, it's just to help us remember that we need to apply the negative throughout. If we do this and keep that in mind, we don't necessarily have to write it that way. Now, we can go on and combine the like terms. Well, x squared minus x squared is 0. Next would be our negative 2x plus 4x is, and 3 plus 5 is plus 8 over x squared plus 7x plus 12. So we've got it all the way down to here. Now we need to make sure that there are no common factors on top and bottom. I do see on the top that it does have a greatest common factor of 2, because we can factor a 2 out. And if we do that, let's see what we're left with. 2 times 2 factored out of 2x is just going to be x plus 4. Well, is 4 a factor of 12? Okay, so there's a good chance that there will be something that simplifies. So we'll need to factor the denominator to make sure. Yes. Works out that x squared plus 7x plus 12 is x plus 3 times x plus 4. Which means our x plus 4 and x plus 4 would cancel, giving us a 2 over x plus 3. And that there is the final answer, because there's nothing else we can do with the x plus 3, and there's no way to simplify it with the 2, because x plus 3 is one whole term. So that's all we have to do for this here. Any questions on any of this here? Let's look at the next one. Now this one here is a little bit different because for the first time today, the denominators are not the same. So we need to get them to be the same. And we do that by multiplying each one of these fractions by the same thing on top and bottom. So looking at the one on the right, what does it have? What does the 7x have that the x squared doesn't? As they both have x, yes? The left one actually has 2. So it does have 1x, but what is it missing? A 7. Because that would get them closer to being the same, yes? Because even though the x squared isn't written as a single x, it does have at least 1x. It's actually got 2. Well, to get the other side to even out, we need to multiply it by just x over x. Questions on this here, how we got to that? So this is going back to our least common multiple to get those two to be the same. So because one has an x squared, well, and that's the biggest exponent with x, so we need them all to have an x squared. Since one of them has a 7, we need them all to have a 7. And at this point here, we can multiply. Well, 7 times 2 is over 7x squared. In the other numerator, we'll have 3 times x, which is 3x. In the denominator, we'll have 7x times x, which is 7x squared. Well, last but not least, we can subtract the numerators since the denominators are the same of 7x squared. And in the numerator, we'll have 14 minus 3x. That's actually it. Any questions on this here? All right. Let's look at the next one here. 1 over 18 x cubed y plus 5 over 27 x squared y cubed. So again, we're going to need to get the denominators to be the same. And we've done a few different ways for figuring out, especially with the numbers 18 and 27, to figure out what we need them to get the same, what the first number that we can turn both of them into. And we've done it by, I showed you one way where we used prime factorization. We did it also with doing the multiples. But one other way we can do is using the calculator. And when we use the calculator, the first thing we'll do is hit math, go over to number, go down to least common multiple, and hit enter. And then we had 27, comma, 18. And if we hit enter, we get that the least common multiple for these two numbers is 54. So we need to get 18 and 27 to be 54. So looking at 27, what do we multiply or need to multiply 27 by to get 54? 2. Because 2 times 27 would get us to 54. Now what times 18 will get us to 54? 3. And we could have also done it in the calculator, 54 divided by 18 and 54 divided by 27 to see what they would be. Now we can look at the x's next. On the left-hand side, we have x to the third. On the right-hand side, we have x squared. So if we want them to be the same, we need it both as x to the third. So the x squared is missing how many x's? 1. Because it's to go from 3 to 2 or 2 to 3, we need 1 more. Because there's 3 on the left, 2 on the right, we need 1 more to get it to be cubed. Any questions on this here? Now we can look at the y's. On the right-hand side, we have y cubed. On the left-hand side, we have y to the first. So how many y's are we missing on the left-hand side? 2. So we need to multiply it by y squared over y squared. And with this here, we will have the denominators the exact same as 54 x cubed y cubed. Now, when we multiply with the numerators, 3y squared times 1 is, well, just going to be 3y squared. 2x times 5, 2 times 5 is 10, and we have our x. And last but not least, we need to add them together. We need to add the numerators together. And since 3y squared and 10x are not like terms, we'll just have 3y squared plus 10x over 54x cubed y cubed. Now looking at this here, is there a greatest common factor between 3y squared and 10x? Is there something that goes into both 3 and 10? Well, no. And there's no variables in common, so there's no way we can actually simplify the numerator or factor the numerator and then simplify. So this is it. This is as far as we can go. Unfortunately, we can't, because we would need something in common on top and bottom, and the 3y squared and the 10x are a single term stuck together. So we would have to pull something out to be able to simplify. Unfortunately, we can't. Any other questions on this here? We ready for the next one? All right. I think these here, where we don't have the single terms with our numbers, a little bit easier to work with. But when we look at this one here, to get the denominators to be the same, the one on the left, what does it need? It needs an x plus 3. But the x plus 3 over here is one term. It's one whole term, so it's different than the x. And then the other side needs our 1x, or x over x, because they are going to be considered two different terms. So the x in the denominator on the left needs an x plus 3. The x plus 3 on the right needs a single x. Now that we have that and see what we need to get the denominators to be the same, and they're going to be x times x plus 3, we can go on and multiply the numerators. Now this one here, with the 5 times x plus 3, we can go on and distribute. And a lot of times when I get to this step here, if it's something that I feel comfortable with multiplying through, I'd go on and do it. But if I feel like it's going to be a little much to try to do that all at once, I'll go on and rewrite it as two sets of parentheses and then do it afterwards. But here, 5 times x is just 5x. 5 times 3 is going to be plus 15. 7y times x is, well, 7xy. Now that we have the denominators the same, we can go on and subtract the numerators. X times x plus 3. Well, the 7xy is not like terms with anything else, the 5x or the 15, so we can't combine it with anything. So we get this here. Now, is there a greatest common factor between 5x, 15, and negative 7xy? There is an x with 5x and 7xy, but the 15 unfortunately doesn't have it. And 7, 5, and 15 don't have any like terms. So that's actually as far as we can take it. If the 15 had an x or an x squared, then we could have pulled something out. Any other questions on these here? Let's look at the next one here. Now this next one, it's going to be very tempting to want to multiply the 3x squared minus 6x by the x squared minus 4x plus 4, and vice versa. But before we can do that, we need to make sure we factor down as far as they will go before we start finding what we're going to multiply by. Now the 3x squared minus 6x, the first thing we want to do is find a greatest common factor with any of them. And if we look at 3x squared minus 6x, it does have a greatest common factor of 3x. And if we factor 3x out of 3x squared, we're left with x minus 2. Because when we factor 3x out of 6x, well, the x will factor out completely. And 6 divided by 3 is 2. Now the x squared minus 4x plus 4, we'll need 2 sets of parentheses. Now since the 4 is positive and the sign in the middle is negative, the signs in the middle will both be negative. The factors of x squared are x and x, and the factors of 4 we want are 2 and 2. Now when we look at the two denominators, both of them already have an x minus 2 as a factor, yes? So that's fine, because the first one does have an x minus 2, the second one does have an x minus 2, but the second one actually has what, a second one, yes? So the first one needs not just one, but it actually needs 2 of them. So we're going to have to multiply top and bottom by an x minus 2 to get the denominators to be the same. And yes, the one on the right is missing a 3x, because the left side has a 3x and x minus 2. The right side already has one x minus 2, it's just missing the 3x. The one on the left has a 3x and x minus 2, but it needs a second x minus 2 for them to be the same. So what we'll need to do here is multiply by the x minus 2. And in the denominator, we'll have 3x times x minus 2. If we want to, we can almost say squared, because we do have 2 of the same one. And over here, we'll have 3x times x minus 2 squared. Now in the numerator, we're going to need to multiply through by the 7. If we feel comfortable with that, we can go on and do the multiplication. We can do 7 times x, which is 7x. If we do the 7 times negative 2, which would be negative 14. On the other side, we have 3x times x squared, which would be 3x cubed. And last but not least, we can go on and add the numerators. And unfortunately for this one here, none of the numerators are like terms, so we'll just have 3x cubed plus 7x minus 14. Now, is there a greatest common factor between 3x cubed, 7x, and 14? No. So there's nothing we can do here. And if we wanted to factor this, we would really either need to know what one of the factors is for us to be able to start, or we would actually need one more term to factor by grouping. Works out this here is the final answer. Any questions on this here? Any questions on anything we've done so far? If you all feel comfortable with this, we'll end it here, because the rest of these really don't add a whole lot to what we've done. So